Okay, good afternoon, everyone. My name is Bill Gibson. I'm a program manager on the SQL organization, and it's my pleasure this afternoon to talk to you about some work we've been doing on sort of identifying and sort of promoting design patterns that can be used with SQL database for developing SaaS applications. So that's the topic of the talk. Lots of things to try and cram in, so I'm going to move pretty quickly. I'm not going to do a kind of an intro to SQL database. I'm sort of hoping you guys are familiar with that. It's our fully managed PaaS service. I mean, we actually tend to call it database as a service. The heart of it, of course, is that you can provision databases as and when you need them. Just create a database when you need it, and when you finish with it, you can remove it. And the real story today is that by doing this, we've actually changed the sort of the dynamics of the SaaS industry in a way, because people in the past had a very different view on how they should think about putting a database behind a multi-tenant application. And by making the creation of databases a very simple and easy task, I think we've changed the dynamics of that process. So that's what I'm going to talk to you about. If we look at the traditional view of the way you think about implementing a multi-tenant database behind a multi-tenant application, it would be to do exactly that, to have a database and to put all your tenants in there, to use some tenant key scheme. You might use row-level security and features like that to protect one tenant's data from another, so that an application wouldn't mistakenly show one tenant the data of another. And you build the application, and as your number of tenants grows, you scale the database, and you simply build a bigger database. Now, I don't want to suggest this is not a perfectly acceptable way of building a SaaS application. It is. But I'm going to show you some other ways and some other opportunities that are now opened up. So one of those is to use a sharded model, and that's nothing new. People have been doing that for a long time. Sharding a model is where you take a set of tenants and you basically put them in a database, so then have another database for another set of tenants. And so now, as you scale up your application, scale out the number of tenants you're supporting, you have an increasing number of databases, and you have to have now some scheme for managing where a tenant is in the database. You need to know which database to connect to, of course. So that's that model. And then the model that people have tried in the past but tended to steer away from is this one, using a database per tenant, actually having individual databases allocated to specific tenants. And of course, the scaling model here is super. It's incredibly elastic. As you create tenants, you create databases. As the tenant goes away, you remove a database. Now, one of the things that's very different about that, but what's held people back from doing that in the past is that you end up with potentially hundreds, thousands, tens or hundreds of thousands of databases, and how the heck do you manage those? And that's been the sort of thing that's kept people away from pursuing this. So one of the key reasons for wanting to pursue this is the isolation model that comes from this. With this model here, you've got individual databases used for each tenant, so the opportunity to have for one tenant to see another tenant's data is extremely reduced. You've now got security isolation, security boundaries. You've got performance isolation. You can give each database a different performance profile. And you've got, you can monitor an individual database, and you're actually monitoring a tenant at that point. You're not trying to sort of second guess what's going on inside a multi-tenant database. When the performance of this database goes bad, is it because of one tenant that was overusing your system? It's very hard to tell. Whereas with this, it's very easy to tell what's going on. And of course, what's going on with this isolation model is, you get a separate database. But with SQL database today, the normal database provisioning model is that you effectively pay for the resources you want to allocate to that database. One of the challenges of this is that if you have, as is common for multi-tenant SaaS scenarios, if you have actually variable usage on those databases. So it's a typical model. You don't know when your tenants are going to log on and use your application. You have no idea how often they're going to use it, when they're going to use it. And so their usage might be, people kicking the tires. They may be intense usage. Users of the system, you really don't know what to expect. And if you want to provision each of these databases with the resources required to support the maximum possible load from every one of those. If you had thousands of those databases, this would now cost you a lot. It's expensive. It would cost us a lot to run the service, to give each of those databases the maximum possible resources that your app might need. But when, as is often the case, people are only actually using the thing sporadically, then that's clearly a poor model. And this is the answer to that. It's to use, you can see that there's a box around the outside here, is to have a pool of resources, and we use the term an elastic pool for this, to assign the resources collectively now for the set of databases, not individually for the databases. And so what was individually unpredictable is now actually collectively stable and becomes predictable. If you put 100 databases into a pool, then you understand the way that those resources are going to be used. And you can understand they get used on an hourly basis. It's much more predictable. On a daily basis, you see trends like this. On a weekly basis, you see trends like this, and you absolutely do see this in usage. And then on an annual basis, this actually is, that might be tax season, or it might be Black Friday there, where you see blips in the curve. And then you can adjust the resources given to the pool now as a way of adjusting resources for all of the applications. So this is real, and we have a reference customer that I've worked with very, very closely, MYOB in Australia. They're an accounting customer, and they are probably our sort of poster child for the use of elastic pools. They have been using SQL database for a long time. They were using it well before we had elastic pools. They were one of the first customers to migrate to pools. And you can see, you just let that number sort of sink in for a moment. They have 130,000 databases running on elastic pools. And this is not a trivial, this is not a toy application. And what's in those databases? Those are the chart of accounts for every one of their customers. So the small businesses that they serve, totally depend on the accounting system that is running in Azure and running on those individual databases. So they're doing this, and their blood pressure doesn't rise. It's the management of this large number of databases is actually. I wouldn't say it's trivially easy, but it's extremely straightforward for them. They've got a highly automated process, and they provision databases, and they've got a whole bunch of things and infrastructure that they've kind of built around this. And what we've done with MYOB and with other customers is we've looked to see what's going on there, what are they doing, and what are the patterns that we can kind of discern from this. So this is what we see, and we see this. This is not, I'm sort of describing this as if it's happening at MYOB only, not at all. It's happening in many of our customer sites. But this idea of using a catalog, for example, is kind of a key idea, that so you know where a tenant's data is located. You know which database is hosting that tenant's data. So, for example, one of the things that they do is they have an offline model, and they will allow a customer to come back and from working offline and create a new database, a new copy of a database. So they switch out a database and retire the old database when they do that. So they need to update their catalog now to point to that new database. So when their application comes in, the online application comes in, it'll connect to the correct database. So there's an example of the sort of a pattern that's got nothing to do with their accounting business, and it represents software they had to write and develop. And so what we're trying to do now is for these kinds of ideas here to lift this up and say, well, what can we do that actually would be usable for anybody in any of the domains? And that's really the story here. So they've built automated provisioning tools so that their clients will come along and sign up, and they don't send an email to someone and say, please, could you create a database? The system creates the database for them. It actually creates it, updates the catalog, and then the next thing the client sees is they're online and now able to enter their chart of accounts into the database. They see exactly this pattern of unpredictable usage. They're running 500 databases in a pool. So they get tremendous averaging. So basically all their pools look the same. They all have this daily hump around, it comes up, goes down at midday. They're running across 2 regions, and they are set up so they could recover from one region to the other if they had to. They're also doing things like they keep multiple schema versions in production. So they have, as part of their provisioning story, they have in the catalog information about their schema version. So they can apply the right schema version when a client comes in and connects and wants to make use of a database. And this has been an interesting scenario we've been working through with them, the idea of recovery of tenant data. So just step back for a moment to the comments about multi-tenant databases. The idea of responding to the call of, we've screwed up, we need you to recover the data. And a database, so we have another very similar customer we're working with who has 120,000 customers in one database. And when we talk to them about this, they just go, their eyes kind of glaze over and they go, we don't offer that service, in fact. Whereas MYOB are able to offer that service. They can recover that database. It's just one database that comes back. They get it back quickly. They can get it from a backup, which, by the way, is automatically maintained for you by a SQL database. So that's a great example. But when they bring that database back, they've got to switch it in, switch out the old one, and update the catalog. So again, cool stuff there. So what can we learn from this? What can we generalize from this? Now, I got into trouble yesterday for making it sound like the only way to do SaaS is with a database per tenant. What I want you to think about is it's a great way to do SaaS, and it applies to some situations. There are pros and cons. If you've got, sort of 20K of data per tenant and 2 million tenants, well, then you're not going to do a database per customer. That's not the model you're going to use, right? So this applies to particularly sort of data-intensive applications. But just watch this slide build here. So if we take database per tenant as the heart of the story, and I said, well, that was the pattern. We'll just watch the patterns that grow around that are these things. I need to provision a database in this story. I want to provision the database, put schema in it. So how do I do that? Give me a simple way of doing that. And what you'll see I bring up here in green are the technologies that can be used. So here, for example, we can use an ARM template, Azure Resource Management template, and a backpack to deploy a database and then put the schema into the database. You can also, as in fact you're going to see in a moment, copy a database. You don't have to do it this way. I'm going to spin this through quickly because there's a lot of things that pop up. So there's the cataloging story that I've talked about. Using the catalog as a connection mechanism. You want that to be efficient. You don't want the catalog to become a bottleneck, of course. You can use the catalog as a place, as a data store, as a database in its own right, an application database for all sorts of applications. Browsing your list of tenants, they're in the catalog. That's where you find out what you've got. You want to put maybe extended metadata there. You've got a lot of other things you want to store. For example, the performance level, which pool you've put that tenant in. If it were to be a disaster and you want to recover that, then you'd want to know how you could reconstruct an exact mirror of the environment as it was. How would you load balance pools, for example, beforehand? Then our performance story there. So using elastic pools, we want to be able to monitor and manage performance of these. And we want an alerting story. So we have a story with the portal, but also OMS, which is a monitoring solution, all-up monitoring solution. It will let you monitor not just databases, but the whole application surface. So it'll let you do things like set alerts across any number of pools. And an alert can then be defined with a query rather than a fact about each pool. So you can just write a query that says, do any of my databases or do any of my pools exceed this threshold at the moment? And you can use that to monitor the app and the data layer. You may want to scale the pool to handle fluctuating workload. So in the evening, you scale it down. In the morning, you scale it up. At the weekend, you scale it down. You might react to this workload. You might do this proactively, as in set a schedule to do that. And you might... in a proactive model, you might do that because you, for example, there's a seasonal change coming up, so you proactively give more resources to a pool to support that. Then the idea of an intense, isolated workload, and we'll see an example of that kind of scenario. But imagine you've got a ticket seller, and tickets are going on sale. It's going to be a mad rush to sell those tickets. You know that you want more performance for that app for a 6 or 10 hour period or something. So you can actually take the database out of the pool, give it dedicated resources for that 6 or 10 hours, and then put it back in again afterwards. And again, this could be any one of those 3 patterns there. Interestingly, and MYOB are really interested in this idea of tenant self-service. Can we actually give the tenant the ability? What about in that ticket selling example, we let the tenant say, I'm going to put, I want more performance for this time period. And the system schedules that move of the database, and then your billing system bills them accordingly. So let's keep going. Load balancing between pools, geo-distribution of pools, so you want pools in different places, you want your provisioning to maybe stripe databases and tenants, you may want to have them localized to specific areas. Auto-provisioning, the idea of actually having the system provision in advance for you. So as you fill up a pool, it gets the next pool ready. As you fill up, you have a limit of 5,000 databases per server. As you get to that limit, you create a new server, create a new pool. So what about this? We don't just auto-provision, but we provision ahead. We pre-provision the databases. If you've got a fixed schema you're going to use, once you've paid for the pool, the databases are free. That's a nice thought, free databases. So you can put the databases in the pool in advance, and then you're allocating a database to a tenant, not creating one for a tenant. And if you don't change the name, that happens in a second. You can allocate them, you just switch the name into the catalog, and now that guy's got the database, and they can be up and running instantly. If you want to rename them, then it's going to take a few moments longer, but it'll take you a couple of minutes to create the database. So onboarding can be much faster that way. Managing schema change, driving schema change. We have an elastic job technology that can push schema changes out over all the tenants. I want to manage the schema versions from the catalog. And go on, I actually wanted to get through this. I really just want you to absorb what's going on there. There's a lot of things that you can do, and there's more space on the right, so I've obviously got more to come here. So this is cross-tenant analytics. This was recovery mechanisms here, geo-recovery, geo-replication. Analytics, I might query across, or I might extract data into a database. And then the last one we've added here is search, and we need to find something to go up here, because that's kind of this empty space there. So that's the sort of set of patterns that we're sort of looking at. And what we're trying to do now is trying to build out examples of these patterns, actually build a sample that's going to... So what we've done from this is we've sort of identified, if you will, a canonical database per tenant application. So this is like the pattern here that we see, the catalog and the tenant databases. And so what we've done is we've built a sample application for you guys to go try and play with. And so we've cutely called this SaaS in a box. It's an application, sample application, deploys in your subscription in Azure. It comprises app services, SQL database, SQL data warehouse, and a whole string of PowerShell management commanders to actually help you, or management scripts rather, to help you manage this. And the real point is, this isn't a product, this isn't actually a platform, but it's a sample. It's a very rich sample give you inspiration to make you see how easy it is to do these things, or at least how it's all possible to do. Installs in under 5 minutes. It's on GitHub, and so let's go there. Where's my mouse gone? Let me just switch this around. So there's GitHub. This is the site. This went live this morning. So pretty exciting. And on here, all the code is there for the app you're going to see in a moment, and a button. And you press the button, and it'll deploy the app. So it'll deploy in your subscription. Takes about 5 minutes. I don't have 5 minutes, but what it's going to do is bring up I've got this nasty feeling I've lost the internet here. Come on. It's going to bring up a template. It's going to log me into the Azure portal. Basically, and there's a template. The template's I'm going to fill in a couple of parameters on the template. This is all was coming up beautifully a few minutes ago. You fill in a resource group name under which it's going to be installed inside your subscription. You want to give it as a username property, and that property is used to make the resources unique, because we're clearly going to deploy the same name resources for all of you when you go and try this out, so we need to make them unique. So your initials and a number or something, because you may do it more than once. So I use BG1, BG2, and this is not cooperating. It's brilliant. Anyway, here's the app, and this may also not cooperate. So this is the app itself. So when you finished installing the app, this is what you're going to see. I've installed this earlier, and what you actually get is you get 3 of the tenants created for you. You're going to get, where are they? I think I'm showing you page 2 there. There we go. So you're going to see the Contoso concert hall. It's Microsoft, has to be Contoso. So there's the app, and it's a ticket selling app. Go and explore it. The key point is each of these is a database. It's a database per tenant. So down in the bottom corner there, you can see there's the database name, there's the server name, and there's the database name. And for each of these pages, you go to your, and you can run scripts to create your own one of these. I'm running out of time very quickly here. So there are a range of patterns to go try. Let's go back to the. So I need to get off here. Come on. Why do things not work when you want them to? Okay, so I need to let me just. So there's a range of patterns. So the application architecture is like this. We've actually got, so it's the same general pattern. There's the catalog. There's the database that we use to copy and create these. As you go through the tutorial, you'll actually create other of these examples. So you'll create a job account for doing job management, for doing schema management, and also for doing controlled export, extract jobs to run and populate a tenant analytics data warehouse. This can be done as a SQL data warehouse or SQL database with column store. We've got both samples there. Ad hoc analytics, if I had more time, I'd show you that right now. It allows you to do queries that span the set of tenants. So you can write a query against a head node database, and the queries fanned out across all the databases automatically. So there's a lot of things here. We've just been playing with adding tenant search. You won't find it's in there yet, but that's coming very shortly. And I need to, with courtesy to my colleagues, I need to get off. What I'd like you guys to do is it's there. There'll be a blog about this in the next few days. But go to this. They're easy to write down. Those aka.ms. Deploy WTP. But really, the place to go to is the GitHub here, because that's got the links, and then the tutorial there. So this deck is going to be loaded up into and available to you all. And I thank you for your time. Sorry, a tremendous rush. We could have shown you more, but this is all they gave us. Thank you very much.